Okay, first of all, you should have no problem getting that the summation of these three forces is a net force of 10 newtons leftward. How did I get that? So first we should do the vector summation of these 240 newtons. So doing the vector summation, you realize it will be this vector here. It's simply just this 40 newtons in this direction, add a 40 newtons in this direction. So this is the resultant of these two forces. And because you could tell that this is just an isosceles triangle, you can divide this into two right-angled triangles. So this length here will be 40 cosine 60, right? 40 cosine 60 will give you the length from this point to this point. But what we want is from here to here. So the total length will be 2 times of 40 cosine 60 degrees. Cosine 60 degrees is a half, so what we get is 40 newtons. So we got 40 newtons due to these two forces, and we have a 50 newtons to the left, so the resultant is a 10 newtons to the left. So what happens to the motion if you experience a net force of 10 newtons to the left? You are going to accelerate to the left. So you are going to speed up towards the left. And now, as the question said, sometime later, we are going to add another 10 Newton force. So on top of these three forces, we are going to add another 10 Newton force that's directed towards the right. So once we have this additional 10 Newton force, the net force will become 0, right? So what happens to the motion when the net force is 0? Do you come to a rest? No, of course not. Newton's first law says that you continue with your current motion. So your current motion just before the 10 Newton force was added was some velocity towards the left. So when the 10 Newton is added, the net force falls to 0, and you should continue going towards the left at a constant speed along a straight line. Alright? So before the 10 Newton was added in, you had a 10 Newton net force, so you were accelerating at a constant rate. But once you have the additional rightward 10 newtons, net force becomes 0, so you continue at your current speed. Okay, ta-ta.